Hey guys, my name is Blaze and welcome back to a new video here for our action RPG series. And today I just want to briefly go over some of the topics that we will be facing throughout the next videos and throughout the entire project, to be absolutely honest with you guys. What I want to cover for now, that's what these primers are for, they're kind of like theory, I guess. What I want to cover today are the 2D arrays and finite state machines. Now, we'll start with 2D arrays, and I'll get to FSM or finite state machines, like I already said, in a moment. So let's start with 2D arrays. And we've already worked with 2D arrays. Remember, in the project, if you're following my project video for video, I started with this view 2D array. And I had direction here, direction, and I had action, right? And then we assigned a sprite to that, right? So I had like a sprite something, right? And that's generally the implementation of a 2D array. But let me just explain for the beginners how the 2D arrays more or less work. If you can imagine direction and action as being an X and Y value, pretty sure you can figure this out now. A 2D array basically stores information into something like a grid, right? Something like this. Not exactly, but that's more or less what it looks like. And inside this huge box that I will draw going around our little grid, I know it's not accurate, but it's pretty close. That is the actual variable here. That's the actual array name. So view is this big box out here on the outside. But direction and action each go into these different cells. Now each cell, remember, has both an X and Y value. And they're all contained inside this object known as view, inside a single variable known as view. That's essentially what 2D arrays are. Now, why am I telling you this after I started the implementation? Well, later on in the series, we will start creating other 2D arrays that hold other information. We will also be using one-dimensional arrays, which only have an X value, really, as a separate thing as well. Now, for now, let's just keep it to sprites. Imagine if your game had, say, instead of just 4 directions, your game had 8 directions. Well, you would still have the same or similar number of directions here. And you would have Y direction as well, or a Y action. Now imagine if you had just 4 directions. Let's go back to 4. So 1, 2, 3, 4. Wow. And 1, 2, 3, 4. Okay, so these 4 would be our directional sprites. Okay, we'll have 4 sprites for idle, we'll have 4 sprites for moving, then we'll have another 4 sprites for attacking, 4, 4, 4, 4. If you can imagine just how hard that would be to program if you had to change the sprite during every single, let's say, frame, that would be really tough on the memory because it has to check that variable if they're moving or not, or if they're doing something else. It's a waste of memory, and it may perform poorly on older computers. So you want to make your game as accessible as possible. Then you're saving time in terms of memory management by using a 2-dimensional array. I don't want to spend too much time on it. In fact, I don't want to spend too much time having to explain this because you guys are beginners and I want to make my tutorials as accessible as possible. If at any point you guys don't understand a particular concept or you want to find out a little bit more, then you can always ask a question. That's what my main difference is between all the other people that make tutorial videos. I'm open to questions and I will try to answer them as much as I can. So essentially, by having a 2D array, you're kind of organizing all of your sprites and all of your data into a single variable. Instead of having one variable for up sprite, one variable for down sprite, and then another and another and another, that's kind of messy and it will get huge. Your variable list will get massive. You don't want that. You want to compact it as much as possible. So by using a 2D array, you're compacting all that information into a smaller, not that much smaller if it does get big, but a much smaller space in memory. Okay, moving on. Let's create a new layer actually, because I want to actually spend a little bit more time discussing or talking about finite state machines. Now, FSM basically means finite state machines. If I can write as fast as I could speak, then that would be awesome, but I can't. So finite state machines. You may have come across these before. I'm not sure. I recently taught this in a class that I teach, actually. The idea of state machines instead of just programming everything in your step event. I'm not teaching 2D, not 2D. I'm not teaching in GameMaker, by the way. I'm using another engine. But the idea of using state machines is not exclusive to GameMaker. In fact, it's actually very commonly used in programming in general, in what's called object-oriented programming. But you don't need to be concerned about that for now. Basically, with finite state machines, we're telling our, let's take our player object. What can our player do? Well, our player can stand still. And what can he do from there? Well, our player can either move or they can attack. Okay, cool. What else could they do? Well, they could also block. Alright, they can block. And can they get hurt while they're standing still? Well, of course they could. What I'm drawing out here is basically what the state machine will look like before we actually start implementing it. So from standing still, they can move, attack, block, but they could also get hurt. Okay, cool, awesome. Now, while they're moving, can they get hurt? Absolutely. While they're attacking, can they get hurt? Well, that's something that's completely up to you. If you think about it, maybe, I don't know, for whatever reason, in your game, the player can get hurt, but they play a different animation. Or maybe when they're attacking, they're invincible for a period of time. That's completely up to you. And by drawing out your state machine here, you're essentially getting an idea of what the player can and can't do while they're doing whatever actions. Basically, what I'm getting at is with a finite state machine, you're restricting what the player can do depending on what the actual character object is doing. So let's say, for example, we're in the attack state. Well, during the attack state, we can't really do anything else apart from play the animation and then, maybe they swing their sword or they cast some magic. Sometimes you want to be able to say, hey, they're attacking, we shouldn't be able to block, or we're attacking and so we shouldn't be able to move if you want to go with the Legend of Zelda style action. It's completely up to you. What the state machine does is it tells you, or it tells the object rather, that hey, we're in the attack state right now, so we can't do anything else until we're out of it. Once you leave the attack state, then you can do whatever else you want. Or maybe from the attack state, they can still get hurt. Alright, so from the attack state, hey, I just got hurt. Listen, we need to do some damage. And then from hurt, if their health is less than 0, HP less than 0, then they die or something, right? I don't know, maybe your character does something after they reach 0 HP, right? So, but you can't die from anywhere else. You can't do that from any other state. By dividing your actions into different states, then what we're essentially doing is we're enabling the player, or we're enabling the code to be a lot neater. Sometimes you may have to change the code a bit depending on how you've designed your game, but essentially with the finite state machine, you're limiting the actions or the kinds of calculations or the amounts of calculations that you have to do depending on where you are. So that's really all I wanted to talk to you guys about, is finite state machines and 2D arrays. Now the next video, it's going to be uploaded very soon actually. We're actually going to start implementing the finite state machines. And again, I will briefly review the 2D arrays in that video as well. So I don't know if any of you guys found this useful. I hope you did, and I hope that this primer actually works for you guys because it is important. It's going to get very important, especially these two concepts, throughout the rest of the series. So that's all from me, guys. I'm going to start work on the next video, which is the cleanup and FSM, finite state machine implementation. And if you have any questions, you want to find out a little more, then don't be afraid to ask because I'm always open for questions from you guys. Anyway, that's all from me, and I will see you later. Bye, guys.